And another unit conversion problem that I wanted to show you, there's a similar one in the review handout that I gave, but I literally just made this one up right now. So if we have 1.47 times 10 to the third cubic inches, that's a volume, cubic inches, how many cubic feet is that? It seems pretty straightforward, inches to feet, but cubic, not inches. So just like any problem in dimensional analysis, don't panic. Write down what you're given, write down the unit of what you want, and go from there. So I'm just going to do that right now, and then deal with the consequences. You don't know until you solve the problem, is it going to take me 1 conversion factor or 12? Hopefully this won't take us 12. So we have 1.4 times 10 to the third cubic inches equals some number of cubic feet. In the handout that I gave you, I did not give you cubic inches to cubic feet. I did give you, I can't remember how I wrote it, 1 foot, 12 inches. But that's inches to the first. Now, when we talk about the exponent for distance, a unit of distance, to the first is a line, which is distance, but to the second, so obviously that's not an inch. Surface area, and put myself on the spot for drawing this, a cube, which is another way of saying now we're measuring volume. We have a unit of volume, we're going to another unit of volume. I've given you a unit of distance. Now, yes, you could Google the conversion, but not on an exam or a quiz. With dimensional analysis, you don't have to do that. So let's go ahead and use what we have. Cubic inches on top, so 12 inches is equivalent to 1 foot. Cubic inches does not completely cancel with inches, because at this point I would have square inch times foot. That's not right. But here is the trick. This is cubic inches. So what if I take this entire value and cube it? What that will do is it'll make this 1 cubic foot and this 12 cubic inches. So numerically the 12 is going to be 12 times 12 times 12, which is a big number that I don't know off the top of my head. I should. And cubic feet. So now I do have cubic inches that cancel, and I have cubic feet. So in your calculator, you're going to take 1.47 times 10 to the third and divide it by 12. Yeah, let's see if I can do this without making a mess out of it. Oops, sorry. Already too late for that. There. Okay, that was right. I gave myself a moment of doubt there. So that comes down to, when you do the math, 0.85, and when we round it to the right number of significant figures, 851 cubic feet. we didn't have the right conversion factor to solve this problem, but we derived it on the fly. And that is such a powerful technique of using dimensional analysis, because otherwise you'll find yourself having to go to the book, having to go to a table, and so forth. But if you can do this, if you can solve a problem like this, deriving your own unit, then you really master this technique. So there are problems like this where you will have to either square it or cube it, but you can do that. So practice this, because if you can do this, like I said, this is kind of one of the higher level techniques for dimensional analysis. And again, cubic inches cancel cubic feet, and that's what we want, right? That was the whole point of the exercise. By the way, 1 cubed is 1, so we are cubing the number 1. 12 cubed, 1728, according to my calculator. So it was 1.47 times 10 to the third divided by 1728 gives me this. Okay? Again, the setup is, in my opinion, much more important than the numerical answer, because we all push buttons wrong on our calculators from time to time.